Today you will look at polynomial and polynomial functions, including classifying. First thing, a monomial. This is just a real number, variable, or product of a real number, and one or more variables with whole number exponents. So a monomial would be something like 2x, because there's only one term. Whereas a polynomial, this is a monomial or a sum of monomials. Okay, so polynomial, we could say something like, oh, that's a highlighter. Like x squared plus 2x plus 1 would be a monomial. The degree is the greatest exponent among the terms. So if we look at our previous example from the polynomial, the degree for this guy here would be 2. And then a polynomial function, if you want a very mathy definition, notice we have our p of x where I have a leading coefficient all the way to the constant. So a polynomial, when we write it in standard form, there is a general term. We can write it as something as such, where notice our exponents are decreasing by 1 and they are separated by addition. Okay, so if we look at our simple example in our polynomial, we have a cubed term, a square term, a linear term, and a constant term. We will write our polynomial with descending powers. So if we look at our box down below, notice we have a degree of 3. We would call that a cubic. There's an example. There are 2 terms. If I have 2 terms in my polynomial, that is referred to as a binomial. If I have a degree of 4, that is referred to as a quartic. We have an example there. Notice we have 3 terms. We call that a trinomial. If we look at our next type of problem, notice we're going to write our polynomial in standard form. And then it says we're going to classify by degree and by the number of terms. So I'm going to look through the example, and I notice our largest power of x is the negative 5x cubed. We'll go in descending power order, so we'll have plus 4x squared minus 6x plus 1. That is our standard form. If 3 is our biggest power, it is a cubic. And because we have 1, 2, 3, 4 terms, we call that a polynomial. If we look at the next example, notice it's 4x minus 5. It's already in standard form. We call it a linear because the power of x is 1. In 2 terms would make it a binomial. I want you to take a couple minutes or two and try the example. You try. Next thing, turning points. Okay, so this is places where the graph changes direction. Okay, so a turning point in our sample pictures here would be where we go from positive to negative or negative to positive. Okay, so all the yellows would be turning points. And then end behavior is where the directions of our graph from the far left and the far right. So we can have 4 different things that can happen. On the far left, notice we are increasing, and on the far right, we are increasing. In the second picture, we are going down on the far left and down on the far right. In the third picture, down on the far left, up on the far right, and then up on the far left, down on the far right. So there's a couple clues that can kind of help us figure out end behavior. Notice if I have a positive leading coefficient and the degree is even, so 4 is an even number, we can say the graph rises to the left and upright. In future reference, like in pre-calculus, if I do x is approaching negative infinity, which would be the left side of the x-axis, we can say the function is approaching positive infinity, meaning the y is increasing, which is the same thing as rising left. Now, if I wanted to say as x approaches positive infinity, so positive infinity would be horizontally to the right, we can say y, or f of x, approaches infinity, which would be this here. Okay, so that would be your rises right. If we look at the next picture, notice the leading coefficient is negative and the degree is even. So I have an even degree, negative leading coefficient. Notice it says the graph falls left and right. So we can write this in set notation. We can say as x approaches negative infinity, meaning as x is getting smaller, y is also approaching negative infinity. Okay. If we continue reading, notice it says we're going to fall left and right. So as x is increasing or going to positive infinity, the graph approaches negative infinity, which means the y value is going down. If the leading coefficient is positive and the degree is odd, notice we have an odd power and a positive 1, the graph is going to go fall to the left. So that means as x approaches negative infinity, which would be negative x values, our y values are also going to negative infinity. And then notice we're going to rise to the right. So as x increases, the y value also increases. Okay? And then finally, if the leading coefficient is negative and the degree is odd, so we have a negative leading coefficient, odd power, the graph is going to rise left and fall right. So if we were to write that in our other type of notation, as x is decreasing, meaning x is moving to the left, the y value is going up, right? Y is going up. And then as x increases to the right, or gets bigger, the y is decreasing. Okay, so just something to keep in mind for future. So in this next type of problem, what we're going to do is we're going to describe our end, left and right hand behavior. And then if you want to check your work using a calculator, you can, but you don't really need to. Notice our largest power of x is this 4, and it's a positive coefficient. That means we're going to go up left and up right. If we wanted to write it in our other notation, that means as x is getting smaller, y is increasing, and as x is getting larger, our y is also increasing. Good. If we look at B, notice we have an odd degree and a negative leading coefficient. If that is the case, I have odd and negative. We are going to go up left, down right. Okay, and if you wanted to write your fancy notation, as x approaches to the left side, our y value is increasing. And as x approaches positive infinity, our y value is decreasing. Take a minute to try the example you tried. Hopefully on A, you had down left, up right, and on B, down left, down right. For increasing, decreasing, and constant, notice a value is increasing when the y value increases as x gets larger, decreasing when the y value decreases as x gets larger, and constant when the y value does not change as x increases. So to kind of help my thought process for increasing, decreasing, I like to draw like a little man, and then notice he's running up the hill. So we can say it is increasing. Now, x is getting smaller, right, as it is continuing to go down. So we can say increasing from negative infinity, and notice he's going to increase until we get to the vertex of this graph, which that x value is -1, right? And then if I put a new stickman when I change direction, notice now he is going down the hill. So that would be our decreasing, and that x value would be from -1 to positive infinity. And that's it. If we look at the picture of the middle, and I start with my stickman, notice he is running down the hill. Remember, we read graphs from left to right. So we will say this one is decreasing from x is negative infinity to 2. And then if I draw a new stickman, he runs up the hill, so we can say he is increasing from 2 to infinity. And then the picture on the right, notice how the little guy is always running on a flat grade. So we would say constant from negative infinity to infinity. Okay, so in our next type of problem, we're going to determine the intervals of increasing, decreasing, and constant. And the one on the left is nice because it's in a bunch of different colors. So notice we're going to put our stickman. He's running up the hill, so that means he is increasing until the x value of -1. And then I'm going to put a new stickman. Now he is constant from x is -1 to +3. And then notice we can also put another stickman. He's running down the hill, so that means he is decreasing from 3 to infinity. The picture on the right, if we start with our stickman, notice he runs down the hill until about x is -2, negative infinity to -2. We'll put a new stickman. Now he's going up the hill, so he is increasing from -2 to 0. And then we can put another stickman. He's running down the hill from 0 to infinity. Okay, so the U just means like a gap, it means or, it means like there is a break. And then we have no constant. Take a second or two and try the U-try. Okay, so notice we are decreasing or increasing. Let me change my color real quick so we can see it better. Increasing from here to here, and then decreasing would be the rest of the graph. Our final concept is the idea of a turning point. So if I have a degree of n, okay, so degree with n could be like 2, could be 3, could be 4, could be whatever. But if it's at least 1, it has at most n minus 1 turning points. Now, if it is an odd degree, you have an even number of turning points. If it is even degree, then you have an odd number of turning points. It's a little kind of weird, but notice there are no turning points, meaning we go from positive to negative or negative to positive. And it has a line, so that means it has a degree of 1, no turning points. Notice in the second picture, notice we have a degree of 2 because the shape is a parabola and we have 1 turning point. So if my degree is 2, 1 turning point. Notice the degree was even and we had an odd number of turning points, okay? If we look at the next picture, notice we have no change in direction, no turning points, but it's still a degree of 3. If we have our other degree of 3, notice we have 2 turning points. So you have to think of turning points as like at most n minus 1. So if I have a degree of 3, that means I can have 2 or 2 minus 2, 0 turning points. 2 or 0 are both even. Okay, our last problem today. Notice we have a set of polynomial outputs, aka an xy table, and you know their inputs and consecutive x values differ by a constant. We can analyze the differences of the consecutive y values to determine the least degree polynomial function. If the first differences are constant, you have a linear function. If the second differences are constant, but not the first, the function is quadratic. third differences, it would be cubic and so on. So if I want to know the degree of the polynomial that generates the data shown, what we're going to do is we're just going to subtract subsequent y values. Now, you can go either direction from left to right or right to left, it does not matter. But what we're going to do is we're going to subtract our y values. Think of it as -1 minus -7, okay? That would be 6. We would have -7 minus -3, okay? -4. We have -3 minus 5 would be -8. 5 minus 11, -6. 11 minus 9, 2. We have 9 minus -7, 16. And notice we did not get the same number. So what that means is we're going to do it again, okay? 6 minus -4 is 10. -4 minus -8, +4. -8 minus -6, -2. -6 minus 2, -8. 2 minus 16, -14. And notice again, we did not get the same number, so we're going to do it again. 10 minus 4 is 6. 4 minus -2 is 6. -2 minus -8 is 6. And -8 minus -14 is 6. So notice we had the same term. We have 1, 2, 3. So we're going to say this one is a cubic. And that's it. Okay, what I would like you to do now is to try the example you tried. Hopefully you found this one to be a quartic. And you are ready for practice. The end.